Section 5.3, Trigonometric functions of any angle. Let theta be any angle in standard position, and let P be a point on the terminal side of theta. The distance from the vertex 0, 0 to xy is called r. R can be found using this formula. To help you remember the formula, notice that x, y, and r are in a right triangle and therefore can be related using the Pythagorean theorem. R squared equals x squared plus y squared, and that relates to our formula by taking the square root of both sides. Note that our point can be in any of the four quadrants. If, for example, it's in the fourth quadrant, then x will be positive and y will be negative. R is always positive no matter what quadrant it's in. We will use these values of x, y, and r to define our six trig functions. Recall that the right triangle trig definition of sine is opposite over hypotenuse, so from theta's perspective, the opposite is y over hypotenuse of r, so our definition will be y over r. For cosine, it's the adjacent over the hypotenuse, so that's x over r. And for tangent, it's opposite over adjacent, so that's y over x. Since sine is y over r, cosecant is r over y. Cosine is x over r, so secant is r over x, and tangent is y over x, so cotangent is x over y. Furthermore, though r is always positive, x could be 0 on the y-axis. So if we have the quadrantal angle of 90 degrees or 270 degrees, x would be 0. And if we have the quadrantal angle of 180 degrees or of 0 degrees, then y will be 0. So therefore, these four functions will have to be restricted that their denominators cannot be 0. In this example, our angle goes through the point 1, negative 3. So that tells us that our x value is 1 and our y value is negative 3, and we can find r. We plug those values into our formula, and that gives us radical 10 for r. We now have x, y, and r, so we can find our trig functions. Sine is y over r, so that gives us negative 3 over radical 10, and we rationalize the denominator. Cosine is x over r, that's 1 over radical 10, and again we rationalize the denominator. Next, we'll find tangent, which is y over x, that's negative 3 over 1, which reduces to negative 3. Cosecant is r over y, that is negative radical 10 over 3. Secant is r over x, that's radical 10 over 1, which simplifies to radical 10. And finally, cotangent is x over y, which reduces to negative 1/3. Example 2. Evaluate, if possible, the cosine function and the secant function at each of the following quadrantal angles: 0 degrees, 90 degrees, 180 degrees, and 270 degrees. For theta equals 0, we can use any point along the positive direction of the x-axis, so we'll select the point 1, 0. To find r, we can use our formula, or we can notice that the distance from the vertex 0, 0 to our point is 1 unit, so r equals 1. We then will find the cosine of 0 degrees. It's x over r, and x is 1, r is 1, so that reduces to 1. Then we'll find the cosecant of 0 degrees, which is r over y. That's 1 over 0, which is undefined, so we'll say that the cosecant of 0 is undefined. If theta equals 90 degrees, then we can use any point that is in the positive direction of the y-axis. So we'll go up 1 unit to the point 0, 1. Notice that r is again 1 unit, so we have our x, y, and r, so we can find the cosine of 90 degrees. X over r is 0 over 1, which reduces to 0. Then we find the cosecant by placing r over y, so that's 1 over 1, which reduces to 1. For 180 degrees, we'll select a point in the negative direction of the x-axis. So we select the point where x is negative 1, y is 0. Again, r is 1. So now that we have x, y, and r, we can find our trig values. The cosine of 180 degrees is x over r, which is negative 1 over 1, which reduces to negative 1. The cosecant of 180 degrees is r over y, which is 1 over 0. So the cosecant of 180 degrees is undefined. For 270 degrees, we select the point 0, -1. So now we use x, y, and r to find the cosine of 270. X is 0, r is 1, so that reduces to 0. And we find the cosecant of 270 degrees, which is r over y, so that is 1 over -1, which reduces to -1. We need to know the signs of the 6 trig functions, and one way to think about it is notice as you move to the right, x is always positive. As you move to the left, x is always negative. As you move up, y is positive. When you go down, y is negative. Because r is a distance, r is positive in all 4 quadrants. Recall that the 6 trig functions are made up of a fraction of 2 out of the 3 x, y, and r values, and so no matter what fraction you make in the first quadrant, the 2 values are positive, so it will reduce to a positive. So in quadrant 1, all the functions are positive. In quadrant 2, notice that the only way to get a positive is if your fraction involves y and r. Since sine is y over r and cosecant is reciprocal is r over y, then those are the only 2 that will be positive. The other 4 will be negative. In the third quadrant, the only way to get a positive is to make your fraction with both of those negatives. So x over y and y over x are the 2 positives. The other 4 will be negative. So in the third quadrant, tangent and cotangent are positive. In the fourth quadrant, the only way to get a positive is to make your fraction with x and r. So that will give us the cosine and the secant. There is a memory device that you can learn. All students take calculus. As you go around counterclockwise, this reminds us that all of the functions are positive in the first quadrant, that sine and its reciprocal cosecant is positive in the second quadrant, tangent and its reciprocal cotangent are positive in the third quadrant, and finally, cosine and its reciprocal secant are positive in the fourth quadrant. Here's an example. If the sine of theta is less than 0 and the cosine of theta is less than 0, then name the quadrant in which the angle lies. We look at our 4 quadrants, and we first take a look at the fact that the sine of theta is less than 0, which means it's negative. Well, it can't be in the first quadrant because all the functions are positive there, and it can't be in the second quadrant because this says the sine is less than 0, and in quadrant 2 the sine is positive. So therefore we must be in one of these 2 quadrants, and the way to determine that is to look at the cosine. The cosine value is negative, so we cannot be in the fourth quadrant, because in the fourth quadrant the cosine is positive. This tells us that we must be in quadrant 3. So our answer is that theta lies in quadrant 3. In this example, we're given that the tangent of theta equals -1/3 and the cosine is negative, and we're asked to find the sine of theta and the secant of theta. Since the tangent, by definition, is y over x, then we know we're in one of 2 situations. Either the negative goes up with the y, or the negative is with the x. But to determine which it is, we have to look at the quadrants. Because the tangent is negative, we cannot be in quadrant 1 because all the functions are positive there, and we cannot be in quadrant 3 because the tangent is positive in the third quadrant. We now look at the cosine being negative, so we know we can't be in quadrant 4 because the cosine's positive there. So we must be in quadrant 2. Well, that tells us that y cannot be -1 because in quadrant 2 you go up in the positive direction of y, and x cannot be +3 because in quadrant 2 you go left, which is where x is negative. So we must be where y equals 1 and x equals -3. So, since the tangent and cosine are both negative, we must be in quadrant 2. That told us that x is -3 and y is 1. We can substitute those values into our formula for r, and when we simplify, that gives us radical 10. We're asked to find the sine of theta and the secant of theta. So we substitute the value of 1 in for y and radical 10 in for r. We rationalize the denominator, and that simplifies to radical 10 over 10. And for the secant, we put the radical 10 over -3, and that simplifies to negative radical 10 all over 3. We're going to define reference angle, which we often refer to as theta prime, and we write it as theta with an accent written up above. The reference angle is the positive acute angle formed by the terminal side of theta and the x-axis. So if theta goes into the second quadrant, then our reference angle will be from the terminal side down to the x-axis. And we find that reference angle by subtracting it from 180. If we're in the third quadrant, then the reference angle goes again from the terminal side to the x-axis, and we'll find the reference angle by subtracting theta minus 180. In the fourth quadrant, we always find our reference angle from the terminal side to the x-axis, so we'll subtract 360 minus theta. Note that we never form our reference angles between the terminal side and the y-axis. For example, if theta is 210 degrees, then that terminates in the third quadrant, so we will find our angle by subtracting 180 from our angle. 210 minus 180 gives us a reference angle of 30 degrees. If theta is 7 pi over 4, we note that that terminates in the fourth quadrant, so we find our reference angle by subtracting 2 pi minus our angle. 2 pi minus 7 pi over 4, we get a common denominator of 4, and that gives us a reference angle of pi over 4. For negative 240 degrees, we note that that terminates in the second quadrant. Our reference angle is the number of degrees from the terminal side to the x-axis, so that's 60 degrees. In this one, theta equals 3.6. Notice that there's no degrees, so this is in radian measure. But you might also notice there's no pi. So when we go to graph this one, we have to think about the fact that pi is approximately 3.14, so halfway around the circle in decimals is 3.14. All the way around the circle is twice that, 6.28. Halfway back from pi is 1.57, and then 270 degrees, or 3 pi over 2, is approximately 4.71. You can get that by taking the approximate 3.14 and multiplying by 3 over 2, which is like multiplying by 1.5. Now we look at 3.6 and we see that that terminates in between 3.14 and 4.71. So that's our terminal side, and we can find our reference angle, theta prime, by subtracting our angle minus 3.14, which gives us a reference angle of 0.46. Finding reference angles for angles that are greater than 360 or less than negative 360, we will find a positive angle that's less than 360, or 2 pi, that is coterminal with our given angle. Then we will draw our angle in standard position, and we'll use the drawing of the angle to find the reference angle, just as we did in the previous examples. Find the reference angle for the following angle. 665 degrees is more than a spin around the circle, so we subtract 360, that gives us 305. 305 terminates in the fourth quadrant, so we subtract 360 minus our angle, so our reference angle is 55 degrees. Find the reference angle for 15 pi over 4. Notice that this is more than one rotation around the circle. One rotation is 2 pi, and since the denominator is 4, 2 pi would be equivalent to 8 pi over 4. 15 is more than 8, so this is more than once around the circle. So first we will subtract 2 pi. We get the common denominator, and that simplifies to 7 pi over 4. That's our theta. We notice that theta ends in the fourth quadrant, so to find our reference angle, we subtract it from 2 pi. 2 pi minus 7 pi over 4, we get a common denominator, and we subtract, and we get a final result of pi over 4. Now we want to find the reference angle for negative 11 pi over 3. Since the angle is negative, we'll have to add in multiples of 360. And since the angle is in radians, we'll have to add in multiples of 2 pi. If we add 2 pi, when we get our common denominator, notice that negative 11 plus 6 would still give us a negative, so this won't be enough of a rotation back to get us into the positives. So instead we'll have to add another multiple of 2 pi for a total of 4 pi. 4 pi is equivalent to 12 pi over 3, and negative 11 pi plus 12 pi gives us pi over 3. And because pi over 3 is in the first quadrant, that's also our reference angle. We can use reference angles to evaluate trig functions, because the values of the 6 trig functions are always the same for theta as they are for theta prime, with the possible exception of the sign. Because theta prime is an acute angle, all of its trig functions have a positive value. But because theta could have been in quadrants 2, 3, or 4, some of its trig functions have negative values. So our procedure for finding the value of a trig function for any angle theta will be to first find the reference angle, theta prime, and then find the trig function value for theta prime. Then we'll determine whether it's positive or negative based on the quadrant in which our original angle theta lies. For example, find the sine of 300 degrees. The first step is to find the reference angle and then the sine of the reference angle. Since our angle is in the fourth quadrant, we find our reference angle by subtracting it from 360, which gives us a reference angle of 60 degrees. To find the sine of 60, we can use our 30, 60, 90 right triangle, and the sine by definition is the opposite over the hypotenuse, and the opposite of 60 is radical 3, the hypotenuse is 2, and so the sine of 60 is going to be the same as the sine of 300, except the sine of 300 may be positive or it may be negative. Since 300 is in the fourth quadrant, we note that the sine of the sine, that's the SIGN of the SINE, is negative, and therefore our value is negative radical 3 over 2. Use reference angles to find the exact value of the tangent of 5 pi over 4. The first step is to find the reference angle and then the tangent of the reference angle. Since our angle terminates in the third quadrant, we subtract our angle minus 180 degrees. Since this is in radians, we'll subtract pi, so we get our angle minus pi, which I wrote as 4 pi over 4 because we need the common denominator. That reduces to pi over 4. So now we find the tangent of pi over 4, which is the opposite over the adjacent. And from 45 degrees, the opposite is 1 and the adjacent is 1, so that reduces to 1. Step 2, we use the quadrant to determine whether that's going to be a positive 1 or a negative 1. 5 pi over 4 is in the third quadrant, and since the tangent is positive in the third quadrant, these values will match, so we get a positive 1. Next, we'll find the secant of negative pi over 6. The first step is to find the reference angle and then the secant of the reference angle. Our angle terminates in quadrant 4, so we can see that the reference angle is pi over 6. However, they gave us a two-step process, so let's double check. Our angle is coterminal with an angle that has one additional rotation, so if we get the common denominator and add, then our angle is equivalent to 11 pi over 6. We still need to find the reference angle. Since that's in the fourth quadrant, we subtract it from 2 pi. Getting the common denominator and subtracting, we get the same pi over 6 that we had seen earlier. So our reference angle is pi over 6, and now we'll find the secant of pi over 6. We'll use our 30, 60, 90 right triangle. Pi over 6 is equivalent to 30 degrees. The hypotenuse is 2, and the side adjacent to 30 degrees, or adjacent to pi over 6, is radical 3. If I have 2 over radical 3, I need to rationalize the denominator, giving a result of 2 radical 3 over 3. In step 1, we found the reference angle and the secant of the reference angle. In step 2, we have to determine if the secant of our original angle, negative pi over 6, is positive or negative. We do that by looking at the quadrant. Our angle is in quadrant 4, and since the secant is positive in quadrant 4, the secant of our original angle will equal the secant of our reference angle, and therefore it will be positive 2 radical 3 over 3.